Now we will learn new concept of voltage and current divider circuit. So it is a important topic of electronics and we will start it with it. So voltage and current divider is by name suggesting that it is a division of the voltage and also a current. So let's take a series circuit and this is the structure or this is a diagram of series circuit. Let's take a 12 voltage applied and with positive sign here, negative here, and 3 resistors, like one resistor with 1 kilo ohm, 2 kilo ohm and 3 kilo ohm. So 3 resistors are in series by one, and we can show it in this way also. So series resistance can be calculated as summation of the R1, R2, R3. So in this case we will find that 1 plus 2 plus 3. So 1 plus 2 plus 3 is equal to 6K. So now proportional voltage formula suggests that V1 by R1 is equal to V by R, because current flowing through all the resistors is same. So V1 is equal to V into R1 upon R. So what is R we have derived here? 6. So V is a 12, R1 is a 1 divided by 6. Same is the case with this. So what is the answer here? 2. In this case it is 12 into 2 divided by 6 is equal to 4. 12 into 3 divided by 6 is equal to 6. So this is a voltage across R1, voltage across R2, voltage across R3. So what is the summation of all these three? Are 2 plus 4 are 6 plus 6 are 12. So voltage across each resistor is same as voltage applied, right? So this formula is valid, right? So we will next move to series voltage divider. So series voltage divider, we will take similar kind of diagram but with different voltage and different resistor. So here R1 is a 15 ohm, R2 is a 5 ohm. So let's find out the voltage drop across this resistor. So what is voltage drop? So as we know, the resistance is the opposed to the current. So what will be appear here? Some voltage applied across this resistor will drop because of this resistance, right? So what is the voltage drop across this is we have to find out, right? So voltage drop across R1, it can be find out by proportional voltage formula. Similarly, so V1 is equal to V into R1 upon R. So here R total is summation of these two resistance. So V is a 10 volt into what is the R1 here, 15, divided by total resistance is 20. So we can find out easily that is this is the voltage drop of 7.5, right? So we can say that the voltage across this point is 10 volt, and by passing the current from this R1 we will get voltage drop of 2.5, that is 10 minus 7.5 of that is 2.5. Next one is V2 into V into R2 upon R. So what is it? 10 into R2 is 5 divided by 20. So what is it? So 2.5, correct? So voltage drop across this resistor is 2.5. So why are this voltage drop are useful in our day-to-day life? So if some appliances like our mobile phone will require only 2.5 volt, and in our circuit, let's say it is 10 volt are there. So what will we do? If we apply 10 volt, our mobile will maybe burn. So we have to save the devices. So we will put some resistance and make it voltage drop to the 2.5 and then apply to our mobile. So that is the one kind of example. So we will next move to what is open in series circuit. So open is kind of the breaking in the circuit. There is no continuity, right? So let's say 10 voltage applied and R1 and R2 are two resistance in the circuit, and there is a open. So there is no connectivity in these 2 points. Let's say A and B. So what open circuit suggests is current is not flowing after this point of A. Let's say current is flowing in this direction and it is stopped at this point. So we can say that there is infinite resistance at A, right? Similar kind of example similarly with the B. So what is the circuit current here is 0, right? So no voltage drop across the resistor. So as we have seen earlier, there is a resistors in the circuit showing the voltage drop, but it is not showing in this case. So 10 voltage will be appear at the point of open, that is A and B. Okay, so what is open in circuit series circuit, suggesting that whole means whole voltage applied would appear across the open, that is A and B. Because what is the reason behind that? Because R1 and R2 is very small as compared to the open, which is infinite resistance, right? So next we will move to short in series circuit. What is short in series circuit? Short means zero resistance. Okay, so what we have learn here, it is an infinite resistance. What we are suggesting here, it is a zero resistance. So what is the zero resistance will do? There may be sudden power increase. So circuit component may burn out. Okay, so let's take a circuit. Here we are taking 10 voltage are applied in the circuit. So voltage is 10 voltage and resistors are 2 ohm and 3 ohm in the series. Okay, so what is the total resistance in here? 2 plus 3, that is 5, right? Next, we know Ohm's law, that is V is equal to IR. So we can write it down like I is equal to V upon R. So what is V here? 10 divided by R total is 5. So we can say 2 ampere, right? So next we have to draw what is the power in the such circuit. So power is V is equal V into I, right? So V can be written as I into R. So what will it become? I square into R. So what is I here? 2 square into R is 5. So total power is 4 into 5, 20, right? So we will next move to what will happen after the short. And what is short is indicating we will put some wire across B and C by passing to the resistor R2. Let's say R1, R2. So resistance R2 is not in the circuit and we are bypassing the R2. So this is, we call it as short in the series circuit. right? So what will happen here? Without short, power is 20. With short is I is equal to V upon R new. What is R new? We will not consider the 3 ohm of R2 here. So it will become 10 divided by only 2, right? So current will be 5 ampere, right? So we will put it in our formula. 5 square into R is 2, right? So 5 square is 25 into 5 into 2, so it is 50. Sorry, yes. So what we are seeing here, there is a multiplication of the power, right? So such a vast power is applied across the circuit, so circuit may burn out, right? So this burning out of the circuit components can be seen in the series circuit. Okay, so next we will move to parallel circuit. What will happen in a parallel circuit, right? So in the parallel circuit, we will take a diagram here. Let's say some voltage applied across the point A and point B. Let's say V voltage. I is a total current passing through it. So let's say 9 ampere. Okay. R1 and R2 are two resistors are in parallel, right? Because they are dividing here and connecting again here, right? So R1 and R2 are in parallel. So as we know, the resistance, to find out resistance in the circuit, we use the formula, that is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2, right? So we will take here R1 is a 2k, let's say R2 is a 4k. Okay, so what is the effective resistance in the circuit? 1 upon Rp into 1 upon 2 plus 1 upon 4, right? So, and it may be denoted like R2 into R1 divided by R1 plus R2, right? So here we can say that 2 by 4 plus 1 by 4, that is 3 by 4, and Rp may be, so Rp will be 4 by 3, right? So now we will find the inverse formula, how it will come. So as we know, to find out current in this R1 resistance, we will consider the R2 is not in the circuit. Okay, so what will happen? I1 R1 is equal to total current in the circuit into total resistance, right? So I is into R is Rp, so R1 R2 divided by R1 plus R2. So I1 R1 R1 get cancelled, right? So I1 is equal to I into R2 divided by R1 plus R2. So here formula will become I into R2 divided by R1 plus R2, and here I into R1 divided by R1 plus R2. So by putting all values, and we get the value of I1 is 6 milliampere, and here we will get 3 milliampere. Okay, so we will get the division of the total current, that is 6 plus 3, that is 9. I'm sorry, it is milliampere. Okay, so we can say sum of the branch currents is equal to total current supplied by a source, right? Next, open in parallel circuit. Similarly, as we have seen earlier, open means there is a breaking in the circuit. So anywhere in the circuit we may find break, then we can say full applied voltage is available across the open. Similarly, we have seen in the series circuit also. So next we will move to short in the parallel circuit. Let's say here we will see there is a short across the R3. So according to series resistor circuit, we can say when we short a particular resistance, then that only get shorted and other resistance will be same. But in this case, all these R1, R2, R3 are in parallel. So when we shorted out one resistor, then all other two get shorted, right? So all R1, R2 and R3 get shorted out. Okay, no current in the shorted resistor, right? So when voltage is applied and the shorted circuit is showing no current in this R1, R2 and R3. Okay, so next point is shorted component are not damaged. As we have seen in the series circuit, it get damaged. It is not the case with the parallel circuit. Why? Because there is no current in the shorted resistors, right? So let's take an example of series and parallel circuit. So here we will take 10 voltage applied across A and B, then resistor R1, R2 and R3 and R4. R2 and R3 are in parallel. So how we will find out the voltage across each resistor is the same as a voltage applied? So we have to find that, right? So what steps will be taken? So first step, we will find out the R equivalent. We'll go in this direction. So we will take R3 and R2 are in parallel. Sorry for the disturbance. Okay, so R3 and R2 are in parallel. So we can use the formula 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Sorry, here it is R2 and R3. So we can easily find out equivalent resistance, and then this resistance will be replaced by one value of R equivalent. So what is the total R in the circuit is R1, and R equivalent will be in series with the R1, then R1 plus R4 plus R equivalent, right? Then step 3 will be Ohm's law. What is it? What is it? V is equal to IR. So I is equal to V upon R, and it's equal to V applied divided by V total. So we have find out R total. Sorry. So we have found out R total here. We can put the value easily. V applied is a 10 voltage. So we can put here and we can get I. So next step will be find out I1 and I2. So there is a division of the current because it is in parallel circuit. As we have seen in the parallel circuit here, same situation is appeared here. So for finding out I1 and I2, we use inverse formula. I will show it for I1. It is I1 is equal to I into R2 upon R1 plus R2. Similarly with the I2 is equal to I into R1 divided by R1 plus R2. Right, we have the all values, so we can put the values in here. We can get I1 and I2. So we have to find voltage drop, right? Voltage drop across R2 and R3. Since it is in parallel circuit, we R2 and R3 in parallel, so we can say that the voltage drop across C and D is equal for the two resistance, right? So voltage drop across R2 and R3 is the same. Okay, next, voltage drop across R1 can be easily find out by Ohm's law, so it is across the R1 voltage drop. Then we will find for R4, and we will take a summation of all these three, and we get final value which is equal to the applied voltage. So sum equals the battery voltage. So this is all about the voltage and current divider circuit. Thank you.